It's working, right? Yes, I think it's fine. Today is Saturday, June 6th, and it is currently just past 4 o'clock in the afternoon. It is actually about to be exactly 4:43 p.m. later today. But as always, this is just the usual demonstration, or rather it is just one specific demo. Since I have recently added it to the system, I would like to go ahead and take a moment to explain that in more detail for you. It was during this year's New Year's holiday, or rather on January 1st. Is this third one. It's called the Domo Hedge Fund. By the way, it's kind of a demo of automated trading for Japanese stocks or something like that. I've been running it, or rather, I created it. This time, I guess you could say I'm making a bit of a foray into US stocks or the American stock market edition. About 2 weeks ago, I put it into full operation. It's been going pretty well so far, so I'd like to explain how I built it and things like that. I'm thinking it'll probably take about an hour, but I don't want to worry too much about the time and just go ahead with it. That's how I usually do things around here. The demos around here are things I made for learning purposes after I joined my current company, and among those, as for number 3 here, it's actually a theme I've liked for quite a while. I've always liked stocks and things like system trading, I've always been interested in those kinds of things. So it was definitely a theme I wanted to try out. Originally, I was doing this with Japanese stocks. It's been about half a year since around January 1st. They provide an API for stock trading. There are more and more securities companies offering this kind of service, and some of them have made it quite easy to implement. So I'd like to explain a bit about that area. First, from a dashboard perspective, what should I call this? Well, this is basically the dashboard for the hedge fund US stock trading. This time, we're focusing on the standard features, or rather, the card features. Not that, but rather its so-called pro code, right? Well, even if you use one of those recently popular coding agents, you can generate it. It's made in a way that lets you do that kind of thing. As for that portfolio tab, it shows what you currently have. For example, these are your positions, like a long position in US stocks. This is the symbol, right? In other words, the stock symbol, what we call the 4-digit stock code in Japan, corresponds to this. Then you have cash long positions, margin long positions, and margin short positions. So for margin trading, it's mainly these 3 types. That's what these correspond to. So which position does each one refer to? Whether you hold them or not is displayed here, and we'll get to that later. But the most important point is the stop protection. Right now it's at 0, isn't it? But from 13, you have it. However, this is the most important part. And when you have the AI agent trade stocks, the key point is what to do with the stock price of the shares you bought right after the order is executed. In the case of a stop sell order for a long position, you place a sell order, and then every 5 minutes, you run the AI agent. But if the stock price changes at that time, for example, if it goes up, then dynamically, like with a trailing stop, right? You raise it a little more like this, gradually increasing it. And then, for example, if the market suddenly changes, it will automatically settle and lock in profits. So basically, that's the kind of strategy we're using. As for the stocks themselves, are you talking about sell orders? If the price reaches this range, how much would it be? If I can sell for more than that, I'll sell. It's called a stop order, and that's the kind of order I'm placing. So-called short selling is exactly the opposite, right? I do that as well. In the case of short selling, it's the opposite approach. This is the portfolio tab, and these are the stocks. But for American stocks, machine learning predictions. Should I call these results? For example, if you type in Dawn and hit enter, it shows the stock price for Dawn, actual results and machine learning predictions. You could call it a comparison of models, which is displayed here. And then things like accuracy rate are also shown. This tab here is for predictions. For example, in this case, it shows what will happen 5 days later, that sort of thing. The buy and sell signals are mainly for Japanese stocks. It's basically the same idea, though. Well, it's about predicting that it will go up. The predictions are generally for long positions, right? If it's predicted to go down as a long candidate, then it's a short candidate. But just like last time, the model, the AutoML and the one created with AutoML, uses the XGBoost algorithm. We're using a regression prediction model and also building models in Jupyter Workspace. This one uses the light GBM algorithm, which is also a decision tree based method. It's in the same family. You could say it's a relative of XGBoost. However, we also use that model as a comparison target for inference. We compare the two models or use both models together. Are they pointing in the same direction or are they facing different directions? We make sure to check things like that. Also, when it comes to model accuracy, we compare it with actual results. For example, let's take Apple, which I personally like. I think it was APL, but it's like, what kind of accuracy does it have? Regarding this metric, you can check whether the accuracy rate is high or low. This is the part of the dashboard that people look at. But how should I put this? This was made with Domo. Actually, this time, rather than just introducing it, I have implemented the API myself. For example, with the securities company I have a contract with, like Webull, a securities company listed on the NASDAQ in the United States. Their API is actually really easy to use. That's why I decided to use them this time. But actually, the smartphone app from that securities company is even better. It's easy to read. So personally, I check whether I'm making a profit or losing money with it, and it's actually pretty interesting. So that's what it looks like. This is the dashboard. Next, to explain things step by step, this is the AI agent. The AI agent is also pretty well integrated into the workflow, and it's been updated quite a lot, about 90 times so far. I've been updating this workflow and making various tweaks on weekends and such. It's actually fun for me. It's a hobby, so I enjoy doing it, just making some adjustments. And here there's a prompt. I've adjusted the prompt about 20 times as well. I've made adjustments quite a few times, and the tool checks the account for Webull Securities, or for example, the stock price of a specified symbol, things like that. There are also functions that can get the latest snapshot, and for accounts, you can see what you currently hold. You can also get information about your portfolio in your general account, cash account, and margin account, like which stocks you own and so on. That's the kind of thing you can do. And then there's the execute trade session, which is for actually placing orders, like placing a sell order or correcting a stock price stop order. It's for actually placing those kinds of orders. So these 1, 2, 3, 4 functions. Well, I created a web group myself using the code engine though. These are the things necessary for stock trading, for buying and selling stocks. And about CreateUpDB, what exactly is that originally? It's the standard one, right? It's the 8 plus version, isn't it? Yes, here. That's right. Every time it's executed, the AI agent leaves a log in AppDB. However, the function to add new entries there and also the search AppDB document are for searching the documents in this AppDB, right? With each search execution, the most recent 10 execution logs of the AI agent are retrieved. That's how it's set up. Such a function is implemented in the code engine and originally quite a bit. The search AppDB document is something provided by Domo. There is a standard feature for this. However, when I tried to have the AI agent handle it, it turned out that it couldn't really provide fine-grained control, so I ended up creating it myself. By the way, there are a total of 6 functions. 1, 2, 3, 4, 5, and 6. I use them. And then as for the AI of Webull, what are the top 3 signals for public relations exploration? The top signals for spot long, margin long, and margin short. Things like public relations are prepared in advance. The dataset is like that. There is a dataset, but then it's further filtered by view. It's filtered cleanly so that the AI agent can easily distinguish it. We have the dataset set up like that. And for example, if we run this, it takes about 4 to 5 minutes per execution. However, in this kind of test, AI agent, I think everyone has tried it out, so you should be able to do it too. Later, I won't be showing the actual movements here, but I'd like to proceed with the explanation. This is the production environment, but right now, in terms of timing, the US market isn't open and it's the weekend, so there's absolutely no issue with the executor, just to clarify. So this is basically what the architecture overview looks like, but as for the overall implementation method or that sort of thing, I'd like to explain that a bit. But first, in order to create the prediction model, just like last time with the Domo Hedge, it's the same as with the Japanese stock fund edition. First, we build a model for machine learning on the data. It's necessary, but this time we're using Jupyter Workspace, right? Should I show it from this side in Jupyter Workspace this time? Which API are we mainly using this time? It's this Webull Securities Web Open API, which is for now in Japan. It also supports other languages, but for Japanese stocks, it's mostly just long positions in actual shares, and it actually provides quite a bit of support. As far as I understand, the API still requires an optional subscription for things like the latest order book information. I'm not really sure what to do about that, but for now, it seems like I can't retrieve it. So I'm just trading US stocks, only buying and selling US stocks, not anything else. The historical data for each stock. I don't quite remember how many years worth it was, but you can also get that kind of data, so you can include that as well. Store it in the database as a data set and then extract features from it, or rather assign features and attach the correct labels. Using AutoML or Jupyter, we build machine learning models like regression models. That's the kind of approach we're taking moving forward. This time we're only using Webull, whereas last time it was about Japanese stocks, so we used JCAR JCons and we obtained the historical data or something like that using Jupyter, stored it on the same platform, and we tried running machine learning on it to make predictions. And then for actually executing trades, we used Tachibana Securities branch, which is quite good. They have an API specifically for Japanese stocks, so we use that to carry out the process. But when it comes to Japanese stocks, well, it's actually quite, this API from Tachibana Securities, you see, it's got quite a few quirks, or rather, it's really for advanced users. It's pretty difficult. How should I put it? Unlike the earlier Webull securities, here you can, for example, place a limit order to buy or set a stop order and so on. Those things are possible, but there are quite a few quirks, and it's pretty difficult, to be honest. It's probably also due to my own implementation skills or lack thereof. And honestly, my technical ability isn't that great either, so I haven't really been able to set it up properly. I just couldn't get it to work. The AI agent would malfunction. There were quite a few situations like that. So with the Homo Strait incident, after various things happened and then there was a sudden change, it was pretty tough. So with the Japanese stocks, I ended up taking a loss. So right now, I've already stopped with the Japanese stocks. So that's where things stand. So this time, just as for Mr. Masataka Tachibana's API, it supports both Japanese stocks in cash and on margin trading as well. It supports those, and also separately. You can get all the historical data and such without having to use things like JCons. So I think it's great for people who can make good use of it. For example, with phone authentication and such, though the authentication methods may have changed recently, you can have an AI agent run everything in a fully automated way. If that's the kind of thing you're aiming for, there are a few tricks or tips involved. So you do need a bit of a knack for it. But even so, I learned a lot from this experience. So this time, instead of using something like JCons from the US, I'll be using Webull Securities, using the API to obtain historical data and perform machine learning. And then the trade execution is also handled here. So everything is done here, including that. The API is really as you'd expect from an American company. There are also quite a few SDKs available, and with Python, for example, Jupyter. If you want to use it there, you can just install the library with pip. So that's all you need to do, and it works fine. But what about when it comes to the high code engine? When you want to use it with an AI agent, you can't use pip to install additional libraries. So you'll need to implement things using just Python's standard libraries. But even so, things like these AI-friendly resources, for example, well, since there are things like this, you can just click on them and then somehow generate or interpret the meaning. For example, things like Codex, Cloud Code, or GitHub Copilot, anything is fine. There are things like, please provide something like this. It's extremely easy to implement. Since it's an API, if you're going to do system trading, I would, at the moment, this is my top recommendation. The smartphone app is also easy to use, and as expected, it's an American company. It's really a top-notch company. I really think so. America is definitely ahead in these kinds of things. So that's the first point. I'd like to start by explaining the process of generating those features. However, now, inside the Jupyter workspace, wait, no, not that specific one. I mean this one right here. First of all, we need to go ahead and gather all of the historical datasets and other related files over in this section. A dataset like this. You can configure it here. But in this case, we're storing it in a dataset called Webull Features Labels Daily. That's basically how it works. This is just for retrieving the data, but it's not just that. How should I put it? Here, we generate both the features and the correct labels. We do it all at once and output a single result. So after this step, all that's left is to do the machine learning part. That's how we're doing it this time. Last time when we did the Japanese stocks version, this is the Japanese stocks version, by the way, generating feature labels. That was actually another workflow step. We would actually fetch the data individually with each Jupyter notebook dataset, and then use Magic ETL to create the features. I worked hard on generating the features, or rather handling the workload over the New Year's holiday. From the perspective of which approach is better, when you look at it from that perspective, in terms of saving time, I think using a coding agent is really, if you just use it and do everything in Jupyter, it definitely feels faster and more efficient. Things just pop right out. But when you start properly checking whether the generated features, or rather the computed results or the attributes that have been added, are actually correct or not, then maybe what you're making with this Magic ETL, the amount of time it takes might not actually be that different. So if you have the time, personally, I think doing this kind of thing visually with Magic ETL and the like is also better for maintenance and upkeep. So is a good approach, I feel. You can immediately see what's being done here, right? If you build it like this, it's really just this kind of source code, This side is machine learning, so maybe it's this side. Generation is faster here, but properly, you do need to check to some extent whether the results are correct or not. That's something you have to do. This is the label generation part. All right, I am going to go ahead and close this window now. So as you can see, I've closed it up just like this, right? As for the features, this is the one from earlier. That's right. The one from earlier, I've already explained this as well. So that's the end of that part. We created the dataset and made the dataset from earlier. So what exactly do we need to do next? Well, first we should take another look at the dataset from earlier, right? Based on that specific dataset we just created in the Jupyter notebook, we can move forward. We're going to further process it like this. Within the labels, or rather within the features, well, within the correct labels, what do we have? This time as well, just like always. 1 business day later, 5 business days later, 20 business 3 days later, we're assigning correct labels of that type. However, for each of those individually, when creating a machine learning model or when building AutoML, at that time here in advance, this is the correct label for the prediction 20 days later is included. That's what it is. But based on that future data set, we create about 3 of them. We're creating seconds models. This one here is the one for 20 days later. And with this data set, well, in the AutoML tab for that child, for example, 3, if you retrain, for example, this is the correct answer. The label is at the very bottom, and this is for day 20. This is the one that contains the correct label after the 20-day forecast. So with that, for example, if it's set to automatic, then it's judged automatically, but basically it's either regression or classification, right? And when you press the train button, well, it also depends a bit on the number of columns and rows, but this time there was quite a lot of data. So maybe I should have trimmed it down a bit more before training even once. That might have been the case, but it ended up taking about 3 to 4 hours. It tries out various models for you, but it's almost always XGBoost, right? With XGBoost, this is what happens. It suggests what might be the best model, and when you deploy it, it gets expanded into Magic ETL. That is how the process works. Please wait just a moment, and that is it. What we did earlier in Jupyter is a feature of Webull. It includes things like the correct labels and features for label generation. Everything is included here, and as you saw earlier, you can filter this in the view like this. Predictions for 1 day later, predictions for 5 days later. That's basically how we're doing it. That's about it. It was something along those lines. Right, so let me think. Where was that spot again? I'm looking to see if there is an inference tile around here. Let me check these options. No, it's not this one I'm looking at. Sorry about that. I mean, there are just way too many open tabs, as always. Let me see now. Is it this one? The specific machine learning model is currently in the process of being actively built. Once that's done, you will be able to see the live inference results right here. This part is the same as always. You just drag and drop the AutoML from the data science tile to perform inference. The actual predictions are made and the results are stored here. Then, for example, predictions for 20 days later or 5 days later, etc. All of those are integrated later, so that's how it works. Additions, we also add labels and so on. This is the same as before the web. When it comes to the latest date for inference targets, basically, inference is performed on the newest data for the latest date. Only the data that has arrived and has not yet been predicted is inferred. That's all you need to do. So just like the features from earlier, from the data with quantity labels, you only take the ones with the latest date. You basically retrieve this with a view. Since it's this kind of view, you can also set it up with SQL and so on. For things like this, wouldn't it be faster to use a coding agent or something? If you generate and create it, it's quick, right? Of course, you do need to check whether the contents are correct or not, though. Okay, so now we're going to run our inference just like this. And also, I think this will serve as a good review for Jupyter as well, or rather a quick recap of the interface. So as you can see here in Jupyter, so we're currently in the process of building the machine learning model, right? Since we're working in Python, I'm trying to recall the exact syntax. Where was it? Was it something like return, predict, or maybe build? Or was it actually the command to train the XGBoost model? I should clarify that we are not actually using XGBoost here. Instead, the function is specifically designed to load the LightGBM library. As we dive deeper into the machine learning components of this project, it is important to note that the predictive model we have carefully built and optimized relies entirely on the LightGBM framework for its performance. You could say it's kind of like a relative of XGBoost. That's right. So that's how it is. As for the model we've built, it's dome shaped like this. This is also a bit of a review, but after deploying it, it's kind of like this, How should I put it? You place an inference tile here in the AI service section. This is the AI inference. In the case of an AutoML model, it's in this data science tile, but for some reason it's over here. But again, it's the same you can use the same approach for inference. So you can also deploy models created in Jupyter to Magic ETL for inference. That's the key point. You can do this. As for the methods, you can perform inference directly on the Magic ETL side, or you can deploy it and perform inference using tiles. Alternatively, you can run inference directly on Jupyter and then store the results in a dataset. That's another option. In the Japanese stocks version, we deployed it on Magic ETL. This time, for the sake of saving time, we're outputting all the inference results to an output dataset by specifying the destination dataset. That is the basic way it works. As for this specific prediction part, it is quite similar to Magic ETL, in that we run this prediction every single day in Jupyter as well. It serves as the input source. For example, when the dataset is updated, it can be triggered to run or something like that. Alternatively, you can also configure and establish scheduled runs. So it is quite similar in that specific sense. In this way, you can also create complex pipelines and perform similar automated tasks. So that is basically how the entire system operates. Now, what do I need to talk about next? We've built the model and we've obtained the inference and prediction results. So that's what we're talking about, right? And after that, it's integrated. This is the AutoML thing I showed you earlier, right? So let's just say we don't need this either. And then take a look at this. I hope you can take a look at it, but as always, it's the same every time. The upper part is the inference from AutoML. Since the columns and items in the results are the same, the lower part is Jupyter. All of these, 1 day later, 5 days later, are basically merged together vertically. It's like they've all been merged together in that way. Yeah, that's about right. It's like making sure the column names and such are written and neatly aligned so you match them up in advance. I think there shouldn't be any issues when you combine them here. But if there are any duplicate rows, just delete them. And then this is for inference. The results are included. Everything is in there. So it becomes a data set where everything is entered vertically. This is what it looks like here. Now, next is the data. We make this into a data set, and previously, after integrating it, how should I put it? The Magic ETL for generating signal labels. That's what we were doing. However, this time, although I just closed this as well. That data from earlier, using the data set as the entry point. It's this one. It contains the signal information. Yes. So we have it set to replace every day. There are about 12,027 of the latest prediction results. Probably there are active listed companies. I think that's the case. But all of them are included. The dataset contains the latest prediction status every single day. It's included like that, and we've also attached some metadata, but this is how we were assigning it at first. So as I mentioned earlier, regarding this specific AI agent, sorry, right over here, it actually looks like the AI agent has completely finished running just like this. In the final report, this is the actual account information, and this is real data, by the way. This is what the cash long position looks like. And for US margin longs and credit longs, the amounts are about like this. And for shorts, there are these kinds of methods, but since it was after hours, they weren't executed. So that's the kind of information you get. However, originally, this AI agent, the previous workflow version of it, not this view, but which one was it? I'm guessing that you all probably do not really need it at all, but I had it set to this one. There were things like having 12,027 rows and so on. Quite a lot of predicted values. Some of them were a bit off, or rather, there were some that were off, right? Things like both models pointing in different directions or having conflicts like this. I created these kinds of things on the Jupyter side as well, but quite a lot of the time, if you give the AI agent these 12,000 rows with missing data or outliers like this, there were quite a few times when it didn't properly find candidate stocks all the way to the end, or when it didn't execute as expected. These kinds of issues happened frequently, so it wasn't very stable. This is a bit of a trick, but I made this the data source for the dataset. I only recently realized this, you could say. At first I was just writing prompts, but I thought I should go a bit deeper. I tried writing various things like dig deeper, but in the end it didn't work out, so I decided to prepare it in advance in a clean view like this. With this, the previous 12,000 lines are now about 200 lines or something like that. How should I put it? Really, both of them. For example, long candidates and short candidates. And if it's margin trading, for instance. First of all, we can easily get information from Webull about whether a stock supports margin trading or if it's a candidate for short selling. So we've already included all of that at the signal labeling stage we saw earlier. Ah, yeah. Well, basically, it's already been properly narrowed down into a clean state. So for these three types, cash long, and margin short, we've properly set the long bias and short bias, and well, we're filtering for clean candidates that we want to target. So out of 12,000, it's like the top 0.02%. Even so, 200 rows should definitely be plenty. So yeah, we've been using this as the trading target for the AI agent. Yeah. And another thing, this Webull holding position snapshot. Wait, not this one. Uh, First, this is different from the signals earlier. It's for the dashboard we saw, so that in the future, when we have a prediction, say for 20 days later, the actual results will come in after those 20 days. This data set was created to continuously accumulate that info so we can later compare the results with the predictions to see the model's accuracy or if it was correct. This is the same as creating the signals earlier. It's being output as a second data set using the same Python program. And well, that's the data set that we're using here is mainly for things like stock analysis, right? And actually, there are two additional data sets as well, such as snapshots by account and uh, also holding snapshots, which are also from Webull. We run it once every hour, and well, it captures a snapshot of that moment. It records which stocks were held and when. And this one too, right, it's a similar format. I think this is the holdings. Anyway, we have those two, and these are also, well, I did everything in Jupyter this time without using Magic ETL or anything. That's the situation. these two, portfolio snapshot and position. Also now for the holdings, it's the holding position snapshot. Yes, basically. So this time, even for the dashboard, I didn't use Magic ETL or standard cards trying to, how should I put it? Let's use Jupyter or something like that. And then let's use the front end pro code. That's the kind of approach we're taking this time. So I've tried it out. I already showed you the integrated one earlier, right? Yes, I did. This is the data set after integration. And this part here, we're referencing it in Jupyter to create those signals we saw before. That's where we are. Once that's done, we move on to the AI agent. We're going to have the AI agent implemented, but when you're giving tools to an AI agent, you generally use the code engine. Speed is important, and while calling Jupyter every time isn't impossible, it's a bit slow, so we don't do it. So these Webull trading functions are in the code engine where we've implemented the Webull functions and deployed them. For example, we use execute trade session to perform actual trades, and this is what you'd call there it is. Execute trade session. So there are 4 public Webull functions. 1, 2, 3, 4. Since they're public, they're set as public functions, not private ones. Anything starting with an underscore is an internal function that the public functions call. I've also implemented the code engine for Tachibana Securities, but compared to that, this is really easy. It's a standard REST API and very user-friendly. Ideally, using the Webull SDK would make implementation even easier, but due to the code engine's limitations in Domo, like not being able to install custom libraries via pip, I followed those specs. I use standard libraries for things like encryption and authentication. I've set up the endpoints and everything here according to those specifications. Yes. And then for a single, execution, like in a trade session, uh, the number of orders you can place or whatever. Also, when specifying symbols for a snapshot, the number you can process at once is, let's see, where was it? Here, max market symbols is up to 30. These kinds of things are controlled on the code engine side using parameters or constants. Uh, so we can set limits. Now, regarding the prompt, I think this is a key point, but in the AI agent's prompt, for example, the latest one, I've rewritten this prompt about 21 times now, but basically in what order, the code engine you can use, like, oh, there are these code engine functions, or for instance, execute trade decision. And well, for this data set, use this view in what order and by what criteria, that kind of thing. It's about 750 lines. If I do any more than that, hallucinations tend to increase. For the Dome AI agent prompt, I think about 750 lines is probably the upper limit based on my experience so far. And well, I've cleaned it up by removing redundant parts and so on. Basically, with things like MCP that are popular lately, where you use coding agent skills to call APIs directly, there's a lot of that. But how should I put it? Depending on the use case, like stock trading, it's not just about calling an API. For example, even if you place a sell order, you can't sell more than the quantity you actually hold, right? And if you try to, well, it might just return an error, and some people might be fine with that. But as much as possible, for something like stock trading, you shouldn't let the LLM call the API directly. It's about proper division of roles. You have it call the API through the code engine and also include a proper safety valve, or in Japanese, a safety guard or safeguard. Like if a certain value comes in, you just send it back without calling the API. You need to handle that properly. If you don't control it, then even if you've made, say, 100,000 or 200,000 in profit, if a stop order wasn't triggered and a stock crashes, then suddenly everything you've gained is gone. The profit is wiped out. That kind of thing happens in system trading. So in cases like this, you really need to implement the API through the code engine and ensure the safeguard part is solid. The AI agent just calls it. Making it work like that is the key point, I think. And well, when you really get into system trading, if you truly push it to the limit, even though I'm doing this AI agent thing for study, it's probably better not to use an LLM at all and just go entirely rule-based. Setting it up with rules like I did in the prompt and just executing them constantly is probably what the real pros, the people who make a living in that industry, are actually doing. And if you really take this to the extreme, you end up with things like HFT that institutional investors do, where they're trading in zero point 0.0 something seconds. I feel like if you push the concept to its limit, that's where systematic trading eventually ends up. But in those cases, they probably set up servers right inside the stock exchange. I'm not sure if that's true. To compete on latency, we individuals just can't do what institutional investors do. So if we're going to do this, I don't think day trading is really the best way to go. I think swing trading, like what we're doing here, raising the trailing stops and using the same approach for both shorts and longs, is better. I've been through more than 6 long, challenging months of trial and error, and so far I'm actually winning. Well, I am winning, at least for now. It's kind of amazing, honestly. It's like with this one particular swing trade approach that I've been using and refining over time, things are finally starting to work out for me. Managing stops for safety is probably the most important part. Out of everything I've tried so far, it's been quite effective. Yeah, for now, I'd say this is the best method I've found, right? So this is the code engine, okay? Also, the standard AppDB search function I mentioned earlier wasn't very useful, so I created another code engine specifically for the AI agent. It uses search AppDB document for searches and returns the 10 most recent logs. That way, the AI agent can just call it without having to process much. It's set up so the logs just come right back like that. And the target for that is this AppDB here. It looks something like this. The data is stored right here, exactly as it was specified in the prompt, down at the very bottom. I've written out the output format in detail, just like the one you would use for create appdb document when registering in appdb. Yes. And then there's this, for the section called execute trade session, I have very carefully and thoughtfully defined the specific format for placing orders, as well as for things like that. Also, if the code engine receives parameters that are incorrect or not as expected, I have made sure to include helpful guidance within the return values that are sent back to the AI agent. By including this information, the AI agent can realize and understand, it failed. This way, the agent is made aware of the issue and can potentially take steps to address or correct the problem in the future. So let me try correcting it and placing the order again. I also make sure to log those failures in AppDB. I always ensure that these are included in the last 10 logs so they can be used as a helpful reference the next time it runs. So that's how it works. It's really quite interesting, this, yes. And well, in this way, after implementing it, well, if you look at this trigger, you'll see what I mean. This one runs every 5 minutes, so even when the market isn't open during those off hours. Webull does actually support after hours trading, but depending on the stock, in my case, it's basically during the core market hours. Since it's daylight savings now, that's around 10:30 p.m. Japan time, right? Until the morning at 5 a.m. Well, unlike the Tokyo Stock Exchange, there's no lunch break between morning and afternoon sessions, I believe. So it's like that. It executes every 5 minutes. And well, for off hours, I've set the prompt to, how should I say, at least perform tasks like selecting candidate stocks. I've set it up that way, but looking at the logs, the AI agent does occasionally slack off, But during core hours, it's quite effective. By neatly organizing the candidate data sets I mentioned earlier, yes, it's running quite smoothly. With this prompt, for a Domo AI agent, 750 lines is probably the limit. I've tried so many variations, and looking at the versions, this is the workflow version. This is version 90 of the workflow, meaning I've revised the workflow or the prompt or the code engine and fine-tuned it 90 times over the weekends. It's just so much fun, I can't help myself. It's a hobby, really, but that's what I've been doing. Yes. And with this, it actually executes trades. For example, in this execution history, it's currently running. But if we look at the previous one and check the AI agent's interaction history, Well, it does things like logging in and performing its tasks. Then there are logs and details about current holdings and also the past order history. I think it's the last 10 entries. Well, I've limited it like that and it executes just right. And finally, it's like this. It registers to AppDB. And once the AppDB save is complete, the AppDB logs accumulate like that. Then for the next execution, how should I put it? Well, it takes the last 10 entries from the AppDB logs and checks them itself to see what kind of failures or events occurred recently, providing that as context. Well, I'm not entirely sure how effective that part is, but yes, it's working. This is the trail. Well, it's like this. As for the flow, first, after logging in, it checks the account info, the latest status, and the logs. Then it determines if dynamic trailing settings are needed for the current holdings and so on. That's how it feels. I do things like that. Well, basically that even if I put in a stop, well, with a stop limit order, if it falls below a certain amount at about what price, what was it? I've set the order so that if the price is above that, I can sell out. For example, even if the market changes suddenly, there are times when it jumps over without hitting that, price. But in those cases, it's basically like an emergency exit. I cancel those two and sell everything. Well, basically, I'm using limit orders, but well, if that's still not possible, I've made the prompt say to do it at market price, though I'm not sure how far it'll go. And then the position to put the stop, what should I call it? The range from the current price depends on whether it's a volatile stock or one that isn't so much. For example, with leveraged ETFs, they can move about 10% in a single day. Since they move like that, I've made the prompt say to give it a little bit of extra room, but honestly, I'm not entirely sure how well it's actually listening. Anyway, I'm trying out various things like that. Once that's done, well, if a trailing stop, or more specifically a dynamic trailing stop setting is really needed, I'll just add it into the execute session during the core hours. After that, I've set it to retrieve about 10 stocks at a time from NetView's dataset. Yes, well, like this. I do that, then evaluate, and then check the current. I check if there's enough margin in the account, if it's in the safe zone, and so on. And then, well, it's order execution, the execute trade session, then it's saved to the AppDB and so on. I'll show you how it works again later because it's interesting. Also for this dashboard, I'm using Jupyter a lot this time and I'm using Domo's custom cards. With these, you can use a coding agent to quickly create something that works to some extent. You can make them. Yeah, like the manifest.json. In places like this with the datasets, the collection in the reference dataset, as you might remember, is the same one we discussed earlier. It's the one from before, just to clarify. Well, I haven't included the code engine or the workflow here in this example, but you could easily imagine having a button right here on the interface. That button could be set up to trigger another workflow when it is pressed, or alternatively, it could start up the code engine for you. You can do things like that, and there are plenty of possibilities. Yes. So in the end, if you choose to use a coding agent, you can certainly create things that not only work well, but also look very good and polished too. It's possible, but how should I put it? Unlike Domo's standard cards and such. Well, to begin with, these values are essentially recognized as web standards. Generative AI can easily create something really cool and interesting using HTML, JavaScript, and CSS. Domo has had this custom creation feature for quite a long time now. And since using a coding agent makes things go faster, there's been a recent trend of, people saying, let's build AI apps. But with just charts like these, you really have to wonder if the values are even correct or reliable. For my own work, I actually used Jupyter instead of Magic ETL. I used it for this demo just to make it look good. In my own case, when I want to check actual profits and similar things, I simply check the Webull Securities mobile app, which is really my main source of truth. So that's basically how it is. You can make some pretty cool things like this stock search feature, which lets you easily find and track stocks. For example, if you type the letter D, it will show you this. Lately, I've been thinking about NVIDIA. Now, is the spelling NVIDIA or is it ND? I'm honestly not sure about that. But, Sometimes these things can be a little confusing, right? Right. I only know AAPL, which is Apple, of course. So, yeah, that's the one I'm familiar with. But still, even though I think we should definitely keep using this kind of technology, and I really do believe it's important, if you're providing it as a service to customers, you really have to make sure, absolutely sure, to verify if it's actually correct, if it's giving the right results. And when you do that verification, when you go through that process, it's crucial to be thorough and careful because accuracy really matters in these situations. You look at the data set plus, for example, this 4,000 line JavaScript file generated by the coding agent that's hard to understand. You know, looking at that, I wonder if you try to verify if it's correct, the amount of work involved would probably be compared to standard cards and such. It might not take that long, or it might take even longer. Also, when you have a data set with tens of millions of rows, these charts are rendered using JavaScript libraries, but with Domos cards, they pop up instantly. But the loading time would probably be very, well, slow. It would likely get slower, I think. So considering all that, while recent coding agents are very convenient and I love using them myself, there's a difference between doing this as a hobby and providing it to customers. So my current feeling is that for things you can do with Domo's standard cards, you should use cards. I think it's best to just build it. And for those parts where you absolutely must, you can just use Procode for that specific section. Well, for now, that seems like the right approach. Of course, you can use Procode to build things like Kintone, business apps, and other things completely unrelated to BI. Lately, I've been building various things like that for clients, almost like a new trend. Well, since this has only just started moving, there will likely be various issues or other things that will come up. That's where we are right now. Yes, those are my initial thoughts on the matter. And finally, let's try running it. Since we have the AI agent here, I'll run it, although I've already been running things like this before, but for demonstration purposes, let's do it again to make it look good. To make it look good, or rather, if I run this as a test, it usually takes about 4 or 5 minutes for the AI agent to run in the background, though the previous run just finished. It starts off like this. First, it calls fetch account context, then it checks the Webull account, and after that, it searches the app following this order. Then, the data comes back, allowing us to see the results. Yes, it works like this. Now, as for the current performance of the US stock version, about a week or so ago, I tried putting in roughly 650,000 yen, which is quite a substantial sum. And there was one semiconductor stock, I can't quite remember the name at the moment, it slips my mind right now. But after I bought it, the price jumped up by about 25%, which was a pretty big move, must say. Then, when the price dropped suddenly, it triggered the trailing stop I had set, and the stock was automatically sold. Yeah, so the current valuation is probably around 720,000. So in a little over a week, it's up about 15% from the 650,000. Wait, no. It's a bit more than that. Was it 650,000 or maybe even 700,000? Honestly, I am not entirely sure right now. Either way, the important thing is that it's up by about 15%, which is a pretty solid increase. So it seems to be going well for now, at least from what I can tell. Since this is still an experiment, I'll definitely keep a close eye on it and carefully monitor how things develop and then decide how to proceed based on what happens. Finally, after more than 6 months of waiting and working on this project, and after all the effort that has gone into it, I'll just have to see what comes next. My weekend research and experiments are finally starting to bear fruit. I'm just doing it for fun, but it's going well. Yeah, I've stepped into the field of systematic trading. It's going reasonably well. I don't know if I can call it a winning pattern yet, but that's where things stand. Yes, market acquisition success and so on. I've included this kind of guidance in the return value. Well, it's to make it easy for the AI agent to understand. Yes, yes, that's right. Meaning I have about 13 stocks as I showed you on the dashboard earlier. That's how it looks. Well, it takes quite a while, so I'll just leave this. Well, I'll go to the end, but it's already been over an hour. Wait, has it? Maybe not. It's almost been an hour. So let's do this last part. Yes, it's quite interesting, isn't it? Let me just. Oh, wait, not this one. I think I opened the wrong one. I opened the wrong one, didn't I? I always have various things ready for demos, but I think I've actually made a bit too many of them. It's the machine learning one, by the way. And this one, this is the dashboard. So let's close the others. Well, I highly recommend the Webull Securities API, so please use it if you're into system trading, as it's very easy to use. Well, this alone should be fine. Also, if you can use the Domo platform, please give it a try. Right, this also takes quite a while to execute, so about 5 minutes. It takes about 5 minutes, but and if you're interested, oh, it's like this. Is this the end? Is it still running? Yeah, like this. The AI agent is working hard, running once every 5 minutes. Um, it's executing it like that. Yes. As for trading, it's after hours here. So either way, an error occurs and the code engine side rejects it, but it's pretty much like this quite a bit. Also a bit, yeah, something like this. Oh, the latest price. Since the market is closed, it says that orders simply cannot be sent at this time. Well, like this. Well, yes. It even saved to the app.db, so that's how it executed. Yes, that's all there is to it. So how was it? System trading is incredibly interesting, so if you're interested, please start. My knowledge isn't anything special, but well, I can share them. Well, these prompts and this code engine, well, at least the source code, I've been using a coding agent to build it, so but well, the GitHub repository isn't public, but if you're interested and well, if you contact me, I can provide all of this. Yes, it's possible. So yeah, that's all. Right now, I'm holding about 13 stocks with 7 longs, spot, margin longs, and 6 short stocks, making 13. And I've properly set the stops too. I've put them in. So there are no unprotected positions. Well, everything is normal. That's how it stands. Yes, that's it for now. Um, thank you very much. It's interesting. So why don't you all give it a try? Within the range, you can enjoy it. That's all from me. Thank you very much.